Coming up, a major moment for 3D printing.
You could just sort of see their minds start to explode when they're like, what? I don't have to have a circular hole?
Science and technology meet true grit.
Those who are questioning whether or not they're going to be able to live a normal life. And I'm here to tell you, you not only can live a normal life, but you can thrive and you can do anything you want to do.
What a century-old whaling expedition tells us about climate change.
Through the frozen winter months, the whalers aboard those ships took note of the temperature, barometric pressure, ice location, and wind directions in the ship's logbook. And it turns out, data like this is valuable to climate scientists today.
It's all ahead.
Funding for this program is made possible by the Corporation for Public Broadcasting, Sue and Edgar Wachenheim III, and contributions to this station.
Hi, I'm Mike Zeman. Thanks for watching SciTech Now. 3D printing is no longer a novelty. The materials are strong, the machines are accurate, and the military is showing major interest in the research happening at one Penn State lab. SciTech producer Bill Hallman has a look inside.
A great design begins with a great idea. It blends form and function to solve a problem. In manufacturing, design is limited by tools and technique, but the tools are changing, and the only limit is imagination.
Additive manufacturing has the potential to truly revolutionize manufacturing. And an important aspect is the ability now to capture the manufacturing process in a digital environment.
The best analogy I have is Minecraft, right? Where kids will play for hours putting little blocks in the right thing to create this intricate structure. We can do that with this technology.
Additive manufacturing is the industry term for what you probably know as 3D printing. Machines that use polymers or metal to build something one layer at a time. Penn State's Applied Research Lab, or ARL, is home to some of the most precise equipment on the market.
With additive manufacturing, you have the machine doesn't care whether you're building a solid block or you're building a very, very thin wall structure. And so if you think about, we could go 70 to 100 microns, basically about half of a human hair. We could build a wall that thick now out of metal.
And detail like that is changing some very basic assumptions.
One of the biggest things we see is challenging designers to think differently. I mean, I joke, well, why are holes circular? Well, it's because that's how we're used to drilling them. They don't need to be anymore, right? And you could just sort of see their minds start to explode when they're like, what? I don't have to have a circular hole? And so things like that, which is really just the tip of the iceberg when it comes to additive.
These machines haven't broken the mold, they've replaced it. You're watching what's called directed energy deposition. It's just one of the machines at ARL's SIMP 3D facility.
Basically how it works is there's 4 copper nozzles down at the bottom of this cone that feeds powder out in all directions. And then a laser comes down through the center of this portion. And then anytime the laser's on, powder's underneath it, the material will fuse into place.
It's like welding, with uncanny accuracy. The machines can create new objects and repair old ones. It can even use multiple materials on a single build. Metals like titanium, stainless steel, aluminum, and nickel alloys. Powder bed fusion is a different approach.
They actually take a vat of powder and they will scrape a small layer on the order of 20 to 60 microns across your building plane, and then the laser will solidify that layer.
The layers are so fine, complicated builds can take days, but the precision is appealing.
One aspect that we're deeply involved with, and have several actually ongoing programs, is the application of the technology for sustainment of military systems.
For the military, additive manufacturing could mean parts on demand, saving time and money by keeping aging equipment in service longer. But there's a catch.
A lot of the standards and protocols that we use for measuring the powder, the process, making sure it's repeatable and reproducible isn't out there for additive yet.
Before a part can go into service, the results need to be predictable, and that means extensive testing. Qualifying a flight-critical component for the Department of Defense can take years. Researchers want to know how the powder performs and if it can be reused. The machines are continually tested for consistency. The parts undergo even more scrutiny. They're tested for strength and fatigue and examined layer by layer for anomalies. But the attention to detail has led to a critical success. The Applied Research Lab partnered with Naval Air Systems Command, or NAVAIR, to make this flight possible. This is a historic moment. The Navy's first manned flight with a critical component created through the additive manufacturing process. It's a titanium link and fitting, small enough to fit in your hand. One of 4 identical parts that helps hold an engine to the wing of V-22 Osprey. The piece was wired during the flight, letting engineers measure performance in real time. This was just a demonstration, the first step towards formal certification, but the Navy has already identified 6 additional safety-critical parts they plan to test over the next year. A clear signal the military is planning on a future with additive manufacturing.
I think it's on the rise, but there's a lot of bumps to get through first. It is very expensive, so people think that we're going to be additively manufacturing everything when that's not actually the case. We're going to be picking the things that would be best to additively manufacture to lower the cost of them.
Bottom line, don't expect a 3D printer like this in every home. At least not yet.
Sure, 20 years, this is going to be pretty mainstream. I think even within the next 3 to 5 years, you're going to start seeing it used more frequently. I sort of joke, nobody wants to be first, but then nobody wants to be last either.
Advancements in medical technology have meant fewer deaths and more solutions for debilitating injuries in the military. Learn how the Orthotics and Prosthetics Lab at St. Petersburg College in Florida is working with veterans to provide mobility in ways we didn't think were possible just a few years ago.
These veterans are up for a challenge. They're climbing the ice floe of a glacier near Mount Denali in Alaska. This is all part of the Combat Wounded Veterans Challenge, an organization based out of Tarpon Springs, Florida.
Our overall mission is to improve the lives of wounded and injured veterans and their families. The challenges are going to be physically demanding, whether you're an amputee or not. They're going to be, in a lot of cases, mentally challenging. You know, the requirements to climb a mountain or stay on a glacier trek for 2 weeks. You know, we'll take anywhere from 6 to 12 veterans on any one of these excursions. And so they get that team environment they left in the military.
The challenge is planned with a greater goal in mind.
First, we look at our research objectives, and then we look at the type of expedition that's going to support those research objectives. For prosthetics, that's kind of was the genesis of the first area that Combat Wounded Veteran Challenge started. We'll take a research prosthetist. So they're in the field right there doing the trek, doing the climb with the veterans. And then along the way, they're taking readings and measurements.
Many of the researchers are students at the Orthotics and Prosthetics program at St. Petersburg College. Here they're under the guidance of Arlene Gillis, the program's director.
The technology in prosthetics has just evolved over the last 30 years. We've gone from a regular joint, hydraulics, and now we're up to microprocessors, and it's amazing to see how the technology has improved the patient health care. To train our students, we actually have patient models come in, and so they'll see a patient, take the history and measurements, create a cast and a mold, and at that point they start their fabrication. They'll modify the plaster to make sure that they've fit the patient properly. They double check the measurements. They build up on areas that they want to have a relief, and they'll shave down on the areas that they want pressure. Once it's smooth, they take it to the thermal forming room and pull the check model.
Laboratory manager Dale Peterson works closely with the students to ensure the highest quality prosthetic.
A device that we call the diagnostic socket or a test socket is created, and it's made with a plastic material. When the patient comes back for fitting, the students can do an evaluation with it and see through the clear socket just how well that socket is fitting.
Patient models like veteran Richard Cicero are a critical part of the student's training. He lives a very active lifestyle and uses a high-tech prosthesis complete with microprocessors.
This knee is called the Genium, and it was truly what was referred to as the first bionic prosthetic device. It knows that if you move a certain way, the knee should not flex. However, if you move other ways, The knee should not only flex, but help you to get up. It gives you the ability to not only walk downhill without tripping and falling, but also to walk uphill and stabilize you and help propel you up the hill. The greatest value of the use of the technology that I have is to bring it to my fellow combat injured service members. Those who are questioning whether or not they're going to be able to live a normal life. And I'm here to tell you, you not only can live a normal life, but you can thrive and you can do anything you want to do.
Fellow veteran David Karras lost his leg in an accident.
It's a hydraulic knee. There's no electronics at all. It does not require any charging or programming.
David's hydraulic knee is not as nimble as Richard's bionic one. He has difficulty going down steps in a normal way. However, the cost is dramatically less, and his system is waterproof. This has proven to be beneficial as a veteran who's participated in the Combat Wounded Veterans Challenge.
One of the adventures I'd been on was mountaineering in Alaska. So I was there for about 2 weeks. About 10 days of that was on a glacier. And then another adventure I went on was a diving challenge, and that was down in Key West, Florida. They looked at the function of our knees. They checked the vacuum, the suction seal, how our legs stay inside the socket at different depths, as well as how fast we can move by using our legs.
At the Key West Challenge, veterans are paired with young divers to work as a team.
And so we pair them up at Moat Laboratories, who does the coral restoration, and give them that mission.
Their mission is to plant coral in hopes of one day having a new reef. Since 9/11, about 1,700 members of the military have had an amputation. However, nationally, over 180,000 amputations occur each year.
So we look at our research where we take 6 to 12 vets, but through that research, we're hopefully going to affect tens of thousands of people that are using prosthetics.
Combat Wounded Veterans Challenge also sponsored a symposium to showcase new technologies on the horizon. Dr. Ranu Jung from Florida International University in Miami shared her research on the neural-enabled prosthetic hand system.
The whole project is to restore lost sensation to an upper extremity amputee. So to give them the sense of touch and give them the sense of hand opening or closing. The way the system works is that you have the prosthetic hand, so you put sensors in them for hand opening or closing, or for grip force, so how hard you grip something. And this information then is to be conveyed back to the person.
The device is under FDA review, and testing with humans is slated for 2016.
Imagine if you were trying to, put up your hair and put a tie up a ponytail, or you were trying to button a shirt. If you have no sensation, then it is a very difficult task. So this is restoring all of that to the person.
Prosthetics has become an industry with tremendous capabilities and a limitless future.
This industry is really just getting started, and it's going to explode in the next few years as we bring technologies in from different areas.
For the wounded veteran, the challenge is to keep on fighting.
Get yourself out there again. Pursue the type of activities that maybe you didn't think you could do anymore, but now you know you can.
I think that the greatest thing that has come out of my injury is to come to understand what I'm still able to do and be able to bring that to my peers. If I can make you want to get up and do something, you're going to get up out of that bed, you're going to get up out of that chair, you're going to get up out of that house, and you're going to start doing and enjoying life. And enjoying life is the key to victory.
Our unique digital traces, or small data, are being collected and analyzed continuously by mobile networks, social media platforms, and search engines. What can we learn about our health through this data? Deborah Estrin, co-founder of the nonprofit startup OpenEM Health, joins us to discuss this trend. So I'm fairly positive that Google knows a tremendous amount about my life, from obviously reading all my emails and figuring out where I am on my maps, et cetera, but how does some of this information about me help me live a healthy, longer life?
Google does know a lot about you, which is how they've so improved search and maps and all those other tools that they give you over time. And it's really not individuals in Google, it's algorithms inside of Google. We are starting to see many ways in which those same data streams can help you as an individual solve your problem, help understand how you're responding to a medication, help you adhere to some behavior that you'd like to do because it's good for you.
How does the idea of what's in a smartphone now change our behaviors, or at least help us learn from the behaviors that we're already performing?
So mobile health is this leveraging a pervasive technology to address pervasive problems, particularly when it comes to chronic disease. 7 out of 10 avoidable deaths are due to chronic disease. 86% of our healthcare costs are due to chronic disease. And very interestingly, there are 4 behaviors that cause a lot of the suffering, reduced quality of life, and mortality associated with chronic disease.
Okay, getting up and moving, I think,
getting
is one
up
of them,
and
right?
moving, what you eat, how much alcohol you drink, and still how much you smoke. There are things that the public policy and that we do as a system, but then there's the individual. And how do I become the best and healthiest and best feeling that I can be? And how do I take care of those chronic conditions that I already have? Because more than 50% of Americans have a chronic condition, at least one. And as we age, we end up with more than one. We end up taking more than one medication. What mobile allows us to start to do is really have things be based on you. How are you doing on and off this medication, with and without this dose, using this form of physical therapy? Whatever is the behavior that you need to do, that somebody prescribes to you to do or suggests that for you to do, how can that mobile technology both really bring back the data of what's working and inform that feedback loop, and also help to prod you along and motivate you to continue to do it or to restart it again when we fall off the wagons, as routinely happens.
So how do we take the data that we're generating and read it and interpret it well? Because let's say I put all that stuff into an app, or the phone is with me, it knows I'm doing the back exercises, I've input exactly what pill I'm taking at what time of day. Now it goes somewhere, maybe to a doctor or a specialist. How do they take all this and sift through it and say, okay, well, it looks like it's not working as well as it could for you?
And that's really where the state of the science and technology is condition at a time, trying to bridge that gap. And you mentioned the word that is sort of part of that solution. In a sense, it's all about apps. It's all about applications that take in data, a lot of which would be passively generated, so you don't have to remember to enter it. Maybe it's actually coming from the pharmacy or a smart pill box. And it's processing that data and making inferences and getting rid of the noise. Yeah, this is vacation week. Just because you're staying at home all the time doesn't mean you've entered a depressive episode or that your arthritis has flared. And just in the same way that Google and our apps have become so much smarter and more adaptive, that same technology, the algorithms that become adaptive and allow things to personalize, can be applied here.
What can an average consumer do today to figure out how to obtain the signals in the first place, gather it, and then give it to the appropriate people to analyze it?
There are a growing number of applications and services that are already in the business of saying, give me access to your Fitbit data, or give me access to your senior elder that you're taking care of, your father, mother, aunt, you might have them wear a Fitbit so that you can track how mobile they are from a day-to-day basis, because you're not always able to visit. So the way that the average consumer needs to go about it, for the most part, is to look for those apps and services that are out there already, marketing to the particular demographic or condition. And they are increasingly having you as part of your onboarding, let them get access to some of your data.
I noticed in your TED Med talk, you said something that was interesting, that was about your father who had passed away, that there were actually signals that he was generating that now, in hindsight, you saw, oh my gosh, certainly there was something coming, but we didn't really know about it. But now I think about it like, well, maybe I should put a tracking watch on the elders in my family and say, explain that.
He was the primary caregiver for my mother, who had slow onset dementia, and he had stopped preparing a meal or two at home during the week for her. They were eating out all the time. And those trips and his patterns in retrospect changed. Now, I have an older sister who's a real doctor. And Margot noticed these changes. But most people don't have that. And truthfully, some of those things we had to catch up with. When he went to see his cardiologist, and the cardiologist asked him, how are you doing? Have things changed? His sense of self was that he was doing fine. And he loved his cardiologist. He wanted to be performing well for that doctor. So I don't think it's so much about you putting a tracking device on your elder relatives, but rather people themselves, as they're living alone and in contexts where they're separated from family members who in the old village context would be observing them all the time, might choose to be able to see for themselves whether their mobility is changing, whether they need a little bit more encouragement to get out and walk around the block. Maybe sometime in the future, we'll even have little agents that run on our behalf around our email and our texting. One of the things that's very difficult to observe is, as I mentioned about my mother, is cognitive impairment. The advances in that field are very important, very slow to progress because we only see patients when they're pretty far advanced into the disease. What if we had agents that were looking at the language we use in our email and our texts, or the way in which we talk to our Amazon Echo, and start to detect changes in those language patterns?
All right, Deborah Estrin, thanks so much for joining us.
Thank you.
At the turn of the 20th century, a huge sheet of sea ice collapsed, trapping a group of 200 whalers against the coast of Alaska for a long, grueling winter. To keep sane against hunger, sickness, and hopelessness, they kept a weather diary to record temperatures, wind directions, and barometric pressure. Scientists today are using these recordings to compare historic weather patterns to current conditions in the Arctic.
The year was 1897. One of the coldest and deadliest in maritime history. But the men aboard the Belvedere didn't know what they were in for, or that scientists more than 100 years later would benefit from their tragic voyage. Every spring, ships headed up the west coast, following the sea ice as it melted back into the Arctic. They were hunting bowhead whales. Their blubber was used for oil, their baleen for women's corsets. It was a booming business. Some say whaling was more lucrative than the gold rush. For the Belvedere, the whaling season of 1897 was going great, until September. A big sheet of sea ice came down out of the Arctic Ocean and pinned the Belvedere and 6 other ships against the coast of Alaska. That left 200 men trapped in the Arctic as the winter set in. 2 nearby ships sink, and all the men pile into the Belvedere, 150 men in one ship. They're running out of food, so they start shooting seals and polar bears. Some get scurvy. One sailor has such a bad case of syphilis that he commits suicide. But what's the one thing they do every day to hold on to their sanity? They keep a weather diary. Through the frozen winter months, the whalers aboard those ships took note of the temperature, barometric pressure, ice location, and wind directions in the ship's logbook. And it turns out, data like this is valuable to climate scientists today. They're gathering it from thousands of old whaling ship logbooks, like the Belvedere's, and plugging it into a big computer program to recreate historical weather patterns and compare them to the way things look in the Arctic today. Bottom line, if you were a whaler today, it would be highly unlikely that you'd encounter the same treacherous ice conditions that the crew of the Belvedere saw. But what happened to those guys anyway? 16 of them died. After 10 months trapped in the ice, though, the rest of them were finally free. But instead of heading home, they went right back to hunting whales.
For the latest in science, technology, and innovation, follow us on Facebook, Twitter, and Instagram. I'm Mike Zeman. Thanks for watching.
Funding for this program is made possible by the Corporation for Public Broadcasting, Sue and Edgar Wachenheim III, and contributions to this station.